Hi, in this video we're going to solve some differential equations, but we're going to find particular solutions when we're given initial conditions. So for example, I'm going to figure out what C is given that x is -2 and y is 1. This is my initial condition. We're still going to follow the same steps we've been following, where we want to get our dy's and our y's on one side, our x's and our dx on the other, and then we can integrate both sides. So I'm going to start by rewriting this. In place of my y prime, I'm going to write dy dx. And now I'm going to move this term over here by subtracting my y, x plus 1. So I get dy dx is equal to -y, x plus 1. And now I can get my y's over here by dividing each side by the y. And over here I'm going to move my dx. So I left with minus x plus 1 dx. Okay? And now I'm ready to integrate both sides. I'm going to integrate left-hand side and the right-hand side. Over here, the integral of 1 over y is just my natural log y. Over here, when I integrate, I'm going to end up with minus x plus 1 squared divided by 2, and then I have my constant. And now to get rid of my natural log, I'm just going to e both sides. Okay, e to the natural log y just gives me y. And over here I can think about this. Remember, I can split this out as e to this part times e to this part, because when we're adding exponents, we're really multiplying things with like bases. So this is like e to the minus x plus 1 is equal to squared over 2 times e to the c. But remember, e to the c is just another constant because e is a constant. So what happens over here is I end up with c, okay? This just becomes c, all right? And then I have e to the minus x plus 1 squared over 2. And now I'm ready to use my initial conditions. This is my x, this is my y. So I get 1 equal to c, e to the minus. Now in place of x, I'm going to write my -2 plus 1, all that squared over 2. Okay, that's going to give me e, or 1 equal to c. This is going to be -1 squared, which makes it +1, but then times a negative, so this is my e to the minus 1/2. Okay, and now in order to solve for c, I'm going to divide each side by e to the minus 1/2. Well, c is going to be equal to 1 over e to the minus 1/2, but remember, I can move this upstairs and make it a positive exponent. So e to the 1/2 is going to be c. And now the way that I write my general solution is I go back up here where I had the c, okay? And in place of my c, I'm going to plug in what I know c to be. So my final solution in this case is y equals e to the 1/2, e to the minus x plus 1 squared over 2. But now notice I have like bases, so the way I can handle that is by adding the exponents. My minus x plus 1 squared is going to end up being a minus x squared minus 2x minus 1 all over 2. And then I'm going to add the 1/2 from over here. All right, notice that if I add the 1, I can just do it under a common denominator. These are going to cancel, the -1 and the 1. So my final answer is y equals e. I've got rid of the 1/2 here. I got rid of this 1 to the minus x squared plus 2x, if I have the negative on the outside, divided by 2. So that's my final answer. I know these are long and they're not always easy, but hang in there. So let's do one more example. All right. Again, building on that concept that we just talked about, where I can break this into two multiples, because when we add or subtract exponents, we're really multiplying things with like bases. So dr ds is going to equal e to the r times e to the minus 2s. Okay, that's the same thing as I have up here. But what that does is make it easier for me to get all my exponents on one side versus the other. So now I can move my e to the r down here, and I can move my e to ds over here. And now once I've separated it, which I have, I can integrate both sides. Okay, All right, this is the same thing as e to the minus r, so I'd need a -1. So the integral is just going to be minus e to the minus r. And over here, I need the -2, so I need to have a -1/2. So this is going to be -1/2 e to the minus 2s, and then plus my constant. I forgot to tell you that we're also given an initial condition here, which is when x is 0, y is 0, or r and s. Okay. All right. Okay, so now I can plug in my r and s and figure out what c is. They're both going to be 0, so this is negative. E to the 0 is just 1, so this is -1, equal to, this is going to be e to the 0, which is 1, -1/2 plus c. And now to solve from c, I can add 1/2 each side, and I get that c equals -1/2. And now I can rewrite this one as minus e to the minus r equal to -1/2 e to the minus 2s minus 1/2. And now notice everything's negative, so I'm just going to get rid of my negative sign. E to the minus r equals a half. All I'm doing here is just get rid of my negative sign on everything. Okay? And now, in order to solve this for r, I can natural log both sides, okay? And I get -r is equal to the natural log of this whole thing, 1/2 e to the minus 2s plus 1/2. Obviously, I can get rid of this negative sign as well. R is equal to negative natural log 1/2 e to the minus 2s plus 1/2. Okay. I can notice that they both have a half, so I can simplify that. I'm just going to move to the top up here, okay, where I have a little bit more room. So I've got r equal to minus the natural log, and now I'm just going to put this under the common denominator, so that would just make it e to the minus 2s plus 1 over 2. Okay. And now with this negative over here, remember that our laws of logs say that this is actually an exponent, so it raises this to the -1. And when we raise this to the -1, that's going to actually give us the reciprocal of this. So it's going to be r equal to the natural log of 2 over e to the minus 2s plus 1. So that would be my final answer. We'll do another example in the next video, but I hope you're starting to get the hang of what you're supposed to do. The gist of it is you just plug in your initial conditions once you solve and figure out what C is. Finding C is not always easy.